Hello, in this video I'm going to solve the following problem for you. So let us read the problem together first. If f is twice differentiable on the interval a to b, and f of a equals f of b equals 0, show that the integral from a to b x minus a times b minus x times f double prime of x dx equals to minus 2 times integral from a to b f of x dx. And there's also a hint given in the problem itself. Use integration by parts on the left-hand side twice. That would be a good idea if you pause the video at this point and try to solve the problem yourself first. Okay, so now let us solve the problem. So I want to use integration by parts as is actually given as a hint. I will use the definite version of the integration by parts formula, which reads as follows. Integral from a to b u dv is equal to uv minus integral from a to b v du. Of course, here we also have to write from a to b. That's the formula that I'm going to use. And of course, it should be clear to you that taking this part to be u and this part to be dv will work better. Because when I take this one to be dv, I need to find v, so I have to integrate this. But whenever I integrate, I am taking one prime out. So that's a good idea. So we will do that. I will take this part to be u and this part to be dv. Okay, and I start finding du and v. Okay, so u is equal to x minus a times b minus x. So then I have to calculate du by differentiating both sides. That's a product rule. The derivative of the first one is 1 multiplied by the second one plus the first one multiplied by the derivative of the second one. The derivative of the second one is minus 1. When I multiply it here, it becomes a minus x. And then, of course, I have dx. So let me now combine these two x's. So I will have a plus b minus 2x dx. So that is du. But now dv is f double prime of x dx. In order to find v, I need to find the primitive function for f double prime, which clearly is f prime itself. Okay, now what I can do, I can call it the left-hand side. The left-hand side is equal to u times v. Okay, this is your u and this is your v. You multiply them, so it becomes x minus a times b minus x multiplied by f prime of x, but I have to run it from a to b, minus integral from a to b v du. So this is v, and this expression is du. So if I want to write them in order, so if you don't mind, let me write a plus b minus 2x first, and put dx here. This is my du, and this is my v. So it becomes f prime of x. Okay, but here, this is 0. Why? Because what I have to do, I have to take this, replace every x with the upper limit. But when I put b here, this term becomes 0. So everything will become 0. Then minus, I have to do the same thing with the lower limit, meaning that I have to replace every x with a, but then this factor becomes 0, and the whole expression becomes 0. So actually, the first term, which is usually in physics called a boundary term, vanishes totally here. So this means that the left-hand side is now equal to minus this integral. And according to the hint in the book, I will use the integration by parts once more. Hopefully it will be clear that this time this is a good choice for u and this is a good choice for dv. Okay, so I will write it here. So u is this a plus b minus 2x. I need du, so du becomes the derivative of this is just simply minus 2 dx. And then dv is this. So v is a primitive function of f prime, and simply v is just f of x. Yes? And then if I want to continue, so let me continue here. So the left-hand side is minus this integral. So I have a minus sign. I open a pair of brackets, and I use this formula once more. So u is this times v, which is a plus b minus 2x multiplied by v, but I have to run it from the lower limit a to the upper limit b, minus the integral of v du. But you see that du contains a negative factor minus 2. I pull it out, so it becomes positive 2, and then I will have f of x dx from a to b. And now I can bring it a little bit closer. Okay, so what we have to do now I have to do the same thing here. I replace every appearance of x with b. I don't need to calculate this because this gives me f of b, and according to the problem, f of b is 0. So when I put b inside here, it becomes 0. For the same reason, when I put a there, it becomes 0 because f of a is also given to be 0. So again, this so-called boundary term is actually 0, and then I will have this minus sign, which is supposed to be multiplied here. So this becomes minus 2 integral from a to b f of x dx. And that is exactly equal to the right-hand side. Okay, so that was the solution to this problem. I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.